Okay, guys. Okay, in this lecture, I will be talking on evaluation methods. Again, I will continue in evaluation methods, and then I will switch to prototyping and how to make prototypes, etc. One interesting factor is the Hawthorne effect. When you are doing experiments, just because you are doing experiments, people like it. So if you say that you are coming from Gebze Technical University and doing experiments in user studies and doing experiment in the performance of the application, they don't behave normally because they are being measured. Somebody is doing some kind of research. So basically, they behave better. So the Hawthorne effect goes back to investigation of the light levels in the factories uh, in Australia. They make improvements and they try to measure whether the lighting affects the production. And they did experiments in factory. Apparently, workers liked the experiment, people measuring things and coming and going. Then their performance increased. Whatever technique is used, it always increased because it is the experiment itself, not the technique, was improving the performance. So the figure, the figure at the bottom says if you start measuring things, people behave differently. Then normal performance will not be achieved. There is nothing much to be done about it. It is always the case, but try to minimize the effect and also be aware that there is such a factor. So once we try to evaluate, first thing we should have in mind that whether the system has correct functionality or whether the functions are correct or not. Then usability comes up as a second uh, measure, such as a clerk is searching the postcode should be able to search postcode or address in the application. What are the problems with the system? Can the functionality be used? So generally, the program should function correctly. Plus, it should function well. So wellness is the how well it performs is usability part. I, I have connected my second screen iPad with cable, but however, it connects through wireless and doesn't update it. Wait a second. Now I switched my tablet to airplane mode. With the airplane mode, then I can transfer two screens without problems. So in the field, when we do experiments in the field, we see the user in the context. We see user to interact with the other people. Collaboration between people can happen. It's noisy and several details are lacking, but it gives a lot of information. There is a secondary technique named cognitive walkthrough. Cognitive walkthrough means the cleaner lady thinks the building is empty and playing the radio. So cognitive walkthrough is doing experiment without actually doing it. My famous example is this. So in this case, Kemal Sunal is cognitively walking through the experiment. So this is how we do experiments without actually doing experiments. So basically, through the description, through the design, we believe that we are doing it, and experts, given to the experts, stepping through the actions and make assessment of usability. Are they performing the task by the action? Can they see the interaction? Can the user tell that it's the right action? Do we have appropriate feedback? So that is how we do cognitive walkthrough. So actually, this is quite interesting because it can be done on design rather than the product. So if you have a design, not the product, you can cognitively walk through the usage scenario and believe that you did the experiment and collect the results. Obviously, that cannot be done with regular, ordinary users. It has to be done by the experts. So usability experts. Since you have taken this class, you will be counted as experts in this, and that's it. Okay. The next one is shortened, a variation of cognitive walkthrough. That is what we call heuristic evaluation. Heuristic evaluation means if you are expert, you know a lot of things in human-computer interaction. So they are developed by golden rules, Jakob Nielsen and Ralph Molich. Each heuristic is used to critique the interface, and experts do the critique. And generally, if we do the heuristic evaluation with 5 experts, then we will find 75% of the problems without doing an experiment. This is extremely interesting. So just asking questions about the interface and fundamental questions, and the answers to those fundamental questions and observations reveals 75% of the problems to correct. Then it's basically a checklist. It's basically a checklist. Sometimes, instead of using the checklist, a free format texture can be used. We call that review-based evaluation. So principles from experimental psychology and literature are used to provide these criteria, such as menu design, naming, icon design, memory, use of short-term memory, long-term memory, etc. of the person. It's again is a review process, just like the heuristic evaluation, but done with the experts rather than the actual users. As all expert-based methods, it's about stimulating basic questions to be asked. So if you write it down one by one, that will be counted as mostly heuristic evaluation. If you do it as a review article or review table, it could be done in tables, then it will be review-based evaluation. Also, try and ensure independence of experts. So if you let experts talk to each other, one of them will dominate. So ask experts independently, then combine the results. That's important. Genelde odada yaşlı biri olunca, mesela toplantı salonunda daha senior biri olduğu zaman onun dediği oluyor. Herkes yön değiştiriyor. O yüzden independent evaluation çok önemli. Uzmanların birbirini ikna etmemesi lazım. And you may use scales and comment fields if necessary. And when doing the experiments, its general name is empirical evaluation. This evaluation concentrates on end users rather than the experts. It's a controlled experiment technique. Generally, we measure one attribute while controlling other attributes, one or more attributes. Various experimental conditions differ only in value of the sum variable. There will be independent variable and there will be dependent variable. Okay. We manipulate, we change, we play with the independent variable and we measure the dependent variable, such as method A versus method B and time to complete the task. So type of method is the independent variable. Time to complete is dependent variable. So or we can change the distance between two dialog boxes or change the distance between two buttons and observe the performance. The performance values are measured variables. Distance is the independent variable. Difference in behavior attributed to different values of independent variable provides different conditions such as interface style, pointing device, and wording. If the independent variable is selecting between two format, I mean, is this better or the other? You are developing a new system and versus the old system, new method versus the old method, or method A versus method B. They are called as A/B test. If you are manipulating a different kind of variable, then it will be regular independent empirical test. Dependent variable must be measurable in some way. So good, bad, better, these kind of subjective statements are not preferred, although sometimes they are necessary too. We ask users questions at the end of the experiment, whether it is good or bad. Even then, you ask questions in a regular way. You ask questions to all users in the same way, with grading from 0 to 5 or 0 to 7 or 0 to 10, whatever you want, and then get the statistics of the dependent variable, like satisfaction. And both subjective and objective measures can be used, but objective methods are more convincing, of course. Of okay. Şu an empirical evaluation'ı görüyorsunuz, değil mi?
Evet hocam.
Anlaşıldı.
Şu an değişti sayfa.
Tamam. So, when doing the empirical technique, first, you need to have an idea. You need to have an idea about something. There is some difference between A and B. There is some difference between the previous condition and the next condition. And you need to have some hypothesis. Without hypothesis, just doing experiment measuring is not sufficient. With the hypothesis in your hand, doing the experiment, a change in independent variable, like playing with A or B, causes changing in the performance. or changing the distance between, changing the size of the buttons changes the performance. So independent variable changes, dependent variable is affected. So the experiment is done in order to prove or disprove the relationship. If there is no relationship, your experiment can be still valid and said there is no relation. For example, whether there is a relation between inflation and the salaries. If you increase the salaries, there will be inflation. That is the hypothesis. And doing the experiment, you increase the wages and measure the inflation. Okay? If there's no relation, then that will be proved as well. So it doesn't make your study bad. However, your study of the literature and hypothesis should prepare you theoretically so that you can estimate the direction. If you have no idea about what's going to happen, it's not good. So it will be totally exploratory. For example, before doing the experiment relating to inflation and wages, you need to have some theory. You need to study previous literature. You need to study mechanisms. So you need to have an idea about what the mechanism is and then doing the experiment. So out of nothing, you cannot do experiment. And it is done through null hypothesis. It's kind of famous. Null hypothesis is famous because you say there is no relation in between. When you say there is no relation, and there is no relation at the end, no harm is done. But if there is no relation, is the hypothesis and it is invalidated, çürütülme, then that means there is a relation. So as a scientific technique, this kind of null hypothesis is commonly used because scientifically it is more correct. Because you don't know whether something exists or not. Can you claim that it exists? What if you cannot find it? Does it make it non-existent? No, it doesn't. But if you start with the hypothesis that it is not existing, and if you find it, it exists. If you cannot find it, hypothesis is still okay because hypothesis said it doesn't exist and you couldn't find it, so no harm is done. It still doesn't exist. But if you say it exists without seeing it, without checking it, you try to find it. If you cannot find it, does it make that it doesn't exist? No, it may still exist, but you couldn't find it. So it is kind of contradictory that way. Therefore, we say it doesn't exist. Then if you find it, it exists. You understand? Enflasyonla maaşlar arasında bir ilişki yoktur diyorsunuz. Bulamazsanız yoktur Gayet düzgün bir cevap. Bulursanız da varmış diyorsunuz. Ama varmış derseniz de bulamazsanız o zaman yamuldunuz. O yüzden varmış deyip de sizin deney sebebiyle, noise sebebiyle bulamamak da mümkün. Hani varmış deyip deney sebebiyle, ölçümler sebebiyle bulamadığınızda yoka gidemezsiniz. Ama yoktan vara geldiğinizde ulan bulduk artık onu geri dönme mümkün değil. O yüzden null hypothesis bilimsel olarak tercih edilir. Bu şekildeki deneysel çalışmalarda. Mesela uçan halı var mıdır? Uçan halı yoktur diye başlıyorsun. Deney yapıyorsun. Var çıkarsa var. Çıkmazsa zaten yok dedin. Ama var dediysen bulamadın. O yok anlamına gelmez. So that is one important thing about doing experiment. Second is the between group and within group experiment design. My famous example is about drugs. Unfortunately, there is a new cheap drug in Turkey who is been affecting young generation a lot, which is called crystal. In rural areas, it is quite common to use people use that kind of drug. And assume that you are doing experiment whether crystal or heroin is more effective. You will do an experiment. You will ask people which one is better or whatever. I'm just joking, so to make it more understandable. If you give heroin and then crystal to the guy, he dies. So you need to do experiment separately. One group of guys take heroin. One group of guys take the other drug. Then you compare the result. That is what we call between group studies. In the between group study, not everyone take everything, because there are some cases when you ask a question, you cannot ask twice. Like an interview with certain limited set of questions, you can do with method A to the user, but you cannot do again because he already learned the result. So you cannot ask the same question. So that kind of tasks, such as solving a puzzle with method A and method B, once you solve the puzzle, you cannot solve it with method B because you already know the result. Therefore, those kind of experiments are between group experiments where you cannot do experiment with the all people. By the way, do you like this kind of video of mine? It's kind of interesting. It's like a TV program. So if everybody does everything, like using the mouse and using the touchpad for the same task, you can ask people to do 2 times. Then we call that kind of experiment as within group experiment, such as everybody is doing everything. So there are some kind of drugs like with the migraine. Some people take aspirin. You can ask questions whether aspirin is good for the migraine. Then next week, you give them something else and ask again. Because taking aspirin this week and taking another drug next week doesn't harm. In that case, the experiment will be within group experiment. What is the advantage of the within group experiment? Tell me. Osman, senden cevap var mı? Videom var. Bak, gördüğüm öğrenciye yapıştırıyorum. Let me explain this way. Within group experiment is less affected from age, sex, education, health conditions, vision, because everybody is doing everything. Like if you have 10 people, 2 of them are computer science students, 6 of them are regular people, and half of them are women, another half is men, etc. Since everybody is doing everything, it's balanced. But between group experiments, some groups could be educated, the next group, group B, could be uneducated. So you cannot understand whether the difference is due to the difference in the education, because education averages of 2 groups are different in that case. So it's very hard to make between group experiments. You need to balance those kind of effects, or discuss, at least discuss in the study at the end of the result. Therefore, between group studies require more population. With the 10 people or 20 people, within group experiment is easy to do, but between group experiments usually require 50, 60, 100, so a lot of people, so that the population biases will be cancelled out. We will be going to elections next month. Is it between group or within group?
Between groups.
It's actually within group because everybody is doing everything. Probably there will be 2 elections. With 2 elections, first election will be performed by the same people. Second election will be performed by the same people. So all the differences will be cancelled out, assuming that they will be attending to the election. Everybody is doing 2 elections, so it is the within groups. But if some people will vote in the first election, if some people will vote in the second election, then the results will be different. So in that case, for the proper result, you need to balance all the other factors, education level, sex, age, whatever, in the both groups. But since it is within groups, there is no need for adjusting the ages and genders, etc. Most of the user interface and interaction experiments can be done using within group studies. Only puzzles, certain questions, magical things. So once you finish, magic goes away, kind of interactions should be done as between group tests. Also, in the within group tests like mouse versus touchpad, you have 10 people. You need to make sure that 5 of them uses mouse first and 5 others uses the touchpad first. So you divide the group into 2 and change the order of execution, because if you give mouse to everybody as a first choice, they learn the task as well. So second time they will perform better. Therefore, in order to cancel the learning effect, half of them will do A first, half of them will do B first. Then they will swap. İyiymiş bu ya. Okay. So this A/B tests and empirical evaluations is good for individual design decisions. How should we proceed, whether direction A or direction B? So what is the effect of size of something? But general evaluation is very difficult. General evaluation is very difficult with data collection and measurement because there are so many things. So overall usability is hard to measure, but for certain parts of the critical parts of the design, experiments, controlled experiments, focusing on the variable is critical. Also, doing experiment is costly, and again, you will be doing projects and thesis in future. You will be collecting data from the users with surveys and other experiments. Please make sure that you give something to the user for their time. This could be a chocolate, candy bar, a book, money, and a flash drive, a flower, something, but give something. Doing experiment, contribution to the experiment and survey for nothing should be avoided, because people don't give enough time to the experiment, and you will have trouble finding the users. It doesn't have to be too much, but you have to give something like a candy bar, depending on what it is. It could be more too. We have done this. We have done this. So about the heuristic evaluation, let me go over what these heuristics are, such as visibility of the system status. We just learned it in the past weeks. The example is progress bars and hourglass icons are used to indicate progress bar task. So how do we do it? We have covered that previously, those heuristics. Basically, we say it does exist or it doesn't exist. Entering new customer information. If you have the evaluation with heuristics, make sure that the experts have some domain knowledge. Train them with the domain knowledge. If it is cargo application. Try to educate them with the cargo functionality and the procedures before letting them to evaluate. Otherwise, the evaluation will be incorrect. Entering new customer information into database, for example, evaluator needs to have knowledge of the type of data being collected. So he has to understand procedures. Either they will study source document or the previous system. So they should understand the scenario. Calling an expert and asking how is it is not a good solution. So doing the heuristic evaluation, as we said, 5 experts can identify 75% of the problems, but have them do the work independently. Okay, have them do the work independently and then combine the results. Each evaluator should make a list of problems with an explanation indicating that which heuristic is violated, such as font color is not good, font color principle is violated, font type changes from one screen to another, which violates the standards, and also should include a fix. Choose a single standard font for the interface. And the heuristic evaluation also gives ratings to the problems. Level 0, level 1, level 2, level 3, and level 4. So no feedback when save is completed. Heuristic guideline 1 is violated. Severity is 2. It is minor usability problem. So severity is 2. These kind of lists will be generated by the experts, and you combine them, discuss them with the developer team and fix them. You don't have to make experiments for this because these guidelines are all available on the internet. As I said, they are initially developed by Jakob Nielsen. Therefore, it is known as Nielsen principles. But those principles are everywhere, so you can go over those principles following any kind of human-computer interaction or usability book. It is also available in ISO 9210 standard. So if you can obtain ISO standard, those guidelines are also written there. At the end, combine the results and discuss with the design team. Design team will not like it because they did it, but being carefully, discussions should include suggestions to fix the usability problems. Must also tell how difficult the problem is to fix. If it is very difficult, you can leave it to the later development stages, because at the end we are engineers, not artists, so nobody is perfect within the constraints of budgets. Heuristic evaluation is fast, cost benefit is the most, and it doesn't require experiments, it doesn't require interpretation of user actions. It's all done by experts. Disadvantages are evaluators may have biases against certain products like Apple or Windows or Android, whatever. That's one example. Problems may be missed because evaluators' area of expertise. This is quite important. Yani evaluator diye beni çağırdınız mesela. Hocam otur şunu bir evaluate et dediniz. Ben başladım yazmaya. Falan ben konuyu bilmiyorum. So I should be familiar. I should be trained with the topic. And then finally, real user behavior is hard to capture. Years ago, some company did interfaces for the gümrük customs in the Zeytinburnu, and as soon as they take it on, trucks made a line up to Tekirdağ, and Vali called the company, said, "Please fix it now, otherwise you will get punished." And the company said, because gatekeepers gatekeeper workers for the truck drivers cannot use computers and the mouse. They were unable to choose sizes of trucks from the menu. They were unable to use mouse because they haven't used the mouse in their life. So they said immediately they run down with the programming personnel. They stand by the gatekeepers and they finished the line coming from Tekirdağ. And in the same week, they replaced the mouse operations with the function keys. If there is a new truck, press F1. If the truck is a small truck, press F2. If the truck is a big truck with the 18 wheelers, press F3, etc. Then they solved the problem. The question was, why didn't they do it before? Because they didn't know how the real user would behave. They said mouse was okay for many people. It will be okay for the workers as well, but worker didn't know how to use the mouse. So that kind of real user behavior cannot be captured with the heuristic evaluation. At the end, we do user testing, and user testing can be done in laboratory or in the field, as I said. When you use subjects and participants are called subjects in the experiment. They should represent eventual users of the system, not your friends. So in gümrük, for example, in customs operations, you need to access to real users. Or in the banking application, you need to access real users. Otherwise, you will have trouble later. Tasks must be selected as representative tasks, not so simple, not so difficult. So representative tasks from each section should be selected. And data is collected, direct observation, video recording, logging into the system, and as we said at the beginning, thinking aloud can be used. We also record error rate and speed with additional software, or we can capture them from the video, screen video, later. So screen video recording along with the video of the user is critical in laboratory experiments. After collecting data, it should be analyzed to see what worked and what didn't. and severity of the problems. Important problems should be indicated so that they should be addressed first. At the end, surveys should be used to collect user opinions about the interface. Users should be asked about specific aspects, and questions must be asked as well. At the end, acceptance testing is done. Usually, in the acceptance testing, time to learn, rate of error, speed of the completion task, retention over time is measured. Acceptance testing is critical for payments. You develop a software, give it to the company. It has to pass acceptance test, then they pay your software. If you cannot pass acceptance test, kabul testleri, then your software means it's not ready. You need to work more. Therefore, as a contract item, acceptance tests could be beneficial for both sides, especially in Turkey, where deliverables are not clear. Writing down the acceptance test makes objectives clear at the end of the project. So the customer cannot say, you need to do this also in order to pay, because your initial acceptance criteria isn't given. And at the end, you have to do it. But if the acceptance criteria is written in the document, and if it is passed by field testing, then you don't need to do anything. Even if they go to court, you will win, because acceptance criteria is given in the document, in the agreement. Typical acceptance test description is, after 1 hour training of the new system, the dental receptionist will be able to enter data about the new patient. This is a typical acceptance test criteria. After 1 hour training, person can use the system. When the system implementation has been completed, the user performs acceptance testing based on the goals established during the initial analysis. During the testing of the interface, it is important to specify measurable criteria so that debates related to user friendliness are avoided. Hiç kullanıcı dostu olmamış abi bu. This kind of debates can be avoided if you specify the acceptance test. Purpose of the acceptance testing is to verify that the requirement documents, specifications, have been met. Once the system has passed these tests, it is usually put into production and field test during active use. After delivery, we still keep collecting data from time to time or through the software, so that next version or updates can be delivered, or new updates, developing new products. This is also critical. All the applications you develop should have some place, should have some form for getting online form for getting user feedback. This is extremely important because when problems occur, users try to reach you, users try to give additional suggestions for future, so or for troubles. This is carefully processed and evaluated for the next versions or for the updates. Remember, that word is interesting. Software is a living thing. It never gets finished. So it is never finished. It's not going to finish. There will always be problems for support, and having close contact with the user helps it. Some people believe that let's not give user feedback form because they will put a lot of information there. We will be bothered, but let them send the feedback. If you don't respond, don't respond, but let them send the feedback. It is better. Finally, we have seen this before, but I will repeat it here. When we have user and the system against each other, each of them observe the other part. User observes the interface. User is inputted by the system through the presentation of the information, and user makes outputs, which we call articulation, as output, and it changes the system state, changes the system state, changes the system performance. So then results are presented by the system. Results are presented by the system, observed by the user. User does something else. When user does something else, system is affected, does something else. So this is what we call execution and evaluation cycle. Okay. Execution evaluation cycle. And it is suggested by Donald Norman. Yeah, I have explained this. So let's give a short break and come back with the prototyping. If you have anything else for asking experiments and observation and user studies, let me know.